I'm going to provide an update on the lower trophic levels of Lake Ontario. And I'd like to acknowledge my co-authors from Cornell Biological Field Station, as well as Ewan Reevy from the University of Minnesota, and Alexander Karateyev and Luba Burlakova from the SUNY Buffalo State. So with the lower food web, we're considering the primary producers, the phytoplankton, often using the proxy chlorophyll. We're also thinking of the primary consumers, so zooplankton and benthic invertebrates. And many of these are important prey for forage fish. We also think about the nutrients of the system, which is important for the carrying capacity of the lake. We generally think of the Great Lakes as an extreme from Lake Superior at very low productivity and downstream Lake Ontario as high productivity. And this contrast was much sharper back in the 80s. Over time, Lake Huron and Lake Michigan have decreased in productivity, as well as Lake Ontario, whereas Michigan and Huron are nearly at the levels of Lake Superior. Lake Ontario still has slightly more phosphorus and hence higher production. You can actually track the changes of productivity of Lake Ontario over time using paleolimnology. This is a diatom-based estimate of total phosphorus from two cores in Lake Ontario. We see that back in the 1800s, estimated total phosphorus was actually similar to today's values, whereas in the 1900s, with land development, agriculture, and industrialization, we sharply increased phosphorus until the mid-70s to 80s, where we reached levels greater than 15 micrograms per liter. This is considerably decreased due to phosphorus management as well as the invasion of dry-standed mussels. And you can see the gray values near the surface are actually monitoring total phosphorus measurements. So you see the model is quite well. We've also monitored phosphorus and chlorophyll using the New York DC biomonitoring program. These samples are collected on a biweekly basis at several stations on the South Shore. We do see that nearshore values are slightly elevated relative to offshore, but generally below the phosphorus goal of 10 micrograms per liter. But for both phosphorus and chlorophyll, we've seen very little evidence of decline since the 1990s. We have seen dramatic increases in water clarity over this time period. So using a very simple Secchi disk, these are for all 5 lakes with spring and summer values from 1985 to today. We see that Lake Ontario has decreased in the spring clarity over time, and Lake Michigan and Huron, which are in blue and green, have decreased even more dramatically to levels even deeper than Lake Superior, which is in yellow. In the summer, Ontario generally is less clear than it is in the spring and has changed very little over time, whereas Michigan and Huron have seen some decreases in the summer. When we turn to phytoplankton, Ewan Reevy has looked at phytoplankton samples over the last couple decades. Generally, the biovolume, both in spring and summer, has not noticeably declined. We have seen community changes in the spring, with particularly dinoflagellates increasing in relation to centric diatoms. In the summer, we do see some increase in cyanophytes, which may be of concern, but generally no change in biovolume. Turning to zooplankton, we look at copepods, which we color blue for the deep calanoids and light blue for the more shallow calanoid copepods. There's also Lake Ontario's has a characteristic cyclopoid copepod population, which we label yellow. And then we also have cladocerans, Daphnia, and non-Daphnic cladocerans, which we identify as red and pink. And these are important grazers of phytoplankton. So if you look at our long-term time series for Lake Huron and Lake Ontario, you see a contrast in behavior and communities. So around 2004, Lake Huron particularly had a sharp decrease in zooplankton biomass and considerably lost the red color, which stands for the Daphnia, the important grazers. Lake Ontario originally had a much higher cyclopoid population, but after 2004, the biomass did not decrease as much, but we do see changes in community away from cyclopoids to more calanoid copepods. More recently, we have seen some decreasing biomass, which has taken us from good conditions to what we consider fair conditions. Now, we do have values for the most recent year, 2024, and there is some good news. We have increased back into the good region, mostly from the addition of more Daphnia. So this is a good sign for 2024, and we'll continue to look at these. Our grad student Steph Figari has looked at several zooplankton indicators, which basically simplify this multi-species data. One thing, as you can see, the changes towards calanoid copepods may indicate more ligotrophication. We do see that Lakes Huron, Michigan, and Superior all have very dominant calanoid copepod communities. Ontario has, which is X'd out in a box, has recently experienced that increase around 2004 to a much higher calanoid population. When we turn to the next indicator, herbivorous cladocerans, this is indicative of decreases in Daphnia in particular. So we see that many of these leaks have decreased in Daphnia, and Superior really hasn't had that much Daphnia. We also again look at aerial zooplankton biomass, which we indicated there has been decreasing trends towards levels of Lake Superior. And then finally, if we look at Lake Trophic State, we see that Ontario as being the most downstream lake. And this is based on Secchi depth, TP, total phosphorus, and chlorophyll. Ontario is generally the highest trophic state or most productive, yet the zooplankton are indicating a much more oligotrophic system. When we turn to mysids, which is an extremely important prey item, we have good news for Lake Ontario. It has decreased slightly over time since the 80s, but we still have a very strong population. So we've marked these in two different time intervals from the early 2000s to the more recent years. Very little decrease, and similar to levels of Lake Superior, which is the least productive lake, but actually has a very strong mysid population. In contrast, Lake Michigan has experienced recent declines in mysid population. That's the blue line and the blue bars. And now the levels of mysids in Lake Michigan are comparable to the low levels of relatively shallow Lake Huron. We do have recent values of mysids from last summer from one program where we got very high values, 315 per meter squared, so in line with this continued sustained population. Now turning to benthic vertebrates, 2023 was every 5 years there's a major benthic survey of Lake Ontario. And this included not just the traditional ponar grebes, but also the benthic imaging system, a set of GoPro cameras looking at the bottom of the lake. And these can be used for round goby assessment. They had deep water housing, so they have a picture at every single one of these 69 sites, which were successful for ponars. The red sites indicate a CSMI site, whereas the green is a long-term monitoring annual site. The blue samples, which are on the north shore and also the southeast shore, were very hard substrates, so there's no ponar, but we did have video. Notably, no Diperia hoyi was collected in 2023, indicating exturbation continued. The benthic imaging system was used to look at Dreissenid mussel coverage, and you can see it did a really good job. These are kind of characteristic photos for each depth interval. So we have less than 30 at an estimated 28.6% coverage of mussels, 50 to 90 meters, which had 38.2%. And then when you get greater than 90, you still have mussels, but it's down to 15.5. So generally the mussels are working their way deeper and deeper into Lake Ontario. So they were able to make these maps of mussel density and comparison to 2018 and 2023. You can see the density overall lake-wide is down from 2018. However, the mussel biomass, so that's in grams wet with shell, so almost a kilogram of mussels per meter squared in wet weight. We can see the mussel biomass has not decreased as much as density, indicating that some of these mussels are actually growing over time. But it does indicate the mussels might be finally plateauing in Lake Ontario, which is something we've been waiting for. With the benthic imaging system, we can do the same type of map with Dreissenid coverage. So we get this lake-wide average of 26.7% coverage by mussels, which is considerable. We recently published a paper on another mussel impact, the loss of the benthic nephloid layers. So early in the 90s, you could see that there was a kind of a hazy layer above the bottom, which actually had large amounts of algae and total phosphorus that actually came from surface water and advanced down to the bottom. But by 2010 to 2019, you see that turbidity, that haziness, has completely disappeared, largely because of mussels. Now on the right, we see some example profiles of what that looks like. So back in the 90s for Michigan and Huron, water clarity or light transmittance was actually down to 60% in the lower 15 to 20 meters of the lake, whereas now it's virtually clear. So this is a pretty major shift in bottom water dynamics and could contribute to changes in benthivorous fish predation on mysids and Diperia, as well as indicates a loss of food to benthic organisms such as Diperia. So finishing up, there's some take-home points for Lake Ontario. Nutrients and phytoplankton biomass are higher and more consistent than the upper lakes. Water clarity has dramatically increased in spring, less in summer. Zooplankton communities have shifted towards deep-living calanoid copepods, and this is generally reflective of increasingly oligotrophic or low productivity settings. Zooplankton biomass has been decreasing to fair levels, but in 2024 it was good, which may be useful for alewife populations. Mysid abundance remains high and stable offshore, which is another good indicator. There were no amphipod diaperia collected in 2023, and that's been the same for the last several years. So essentially it is extirpated. Currently, Lake Superior has the primary diaperia population in the Great Lakes. And some final news is the quagga mussel abundance does appear to be plateauing between 2018 and 2023. So this is something we've been waiting for a while, and perhaps a good sign. So I'd like to thank you, and I'm happy to take any questions. Thank you.